For this question, sketch the region bounded by the curve for y equals to x exponent x squared, y equals to x squared for x greater than 0, and the line for x equals to 2. Find its area. So we have to sketch for this graph. For the first quadrant only, when it stated x greater than 0, means only we notice for the first quadrant. So for the first graph, where y equals to x exponent x squared, actually is a exponential graph. It will be shooting up, starting from when x equals to 0, y equals to 0. So it will start from origin, and then it's curve up. Then we label our graph. Then for second graph, where y equals to x squared. So this is a quadratic graph. Starting point x 0, y also 0. So notice that both graphs also curve out, but for x squared, it will be having gradient of the graph more steeper than quadratic. So the quadratic graph will be beneath than this x exponent x squared. So this is our quadratic graph. And the line of x equals to 2, x equals to 2 is a vertical line. So vertical line, straight line, intersect as x-axis. So x equals to 2. So you can see the region bounded for this curve, and then quadratic, and then the line. So the region that we refer here will be at this. So in order to find the area, we can see this is the area. We can observe the region vertically. So means that we're going to finding our area using the concept of two curves. So the curve above minus the curve below respect to x. So we can see this graph vertically. So we are going to refer to x. Therefore, we have to find out the lower limit and the upper limit. So the lower limit obviously is 0. Upper limit, the region can go up until the highest value here is 2. So for the curve above it, the curve above it will be x squared, and then the curve below it will be a quadratic minus x squared. So this is our formula about this region. Then we're going to integrate this. So to integrate x squared. So for this, we can refer our special formula about our exponential, where we having a special formula pattern EFX. If we have a differential function multiply with our exponential function, to integrate this pattern, we can straight away we get EFX plus C. So we can see our power here, where it is not linear, so it will be our function of x squared. And then when we differentiate this x squared, it will be 2x. Notice that we have a pattern of this formula. So where we still lacking of a coefficient 2. So in order to integrate this, we have to get to the pattern first. We're going to multiply 2 inside our formula. So I separate this integration. We can integrate the function one by one. So now I'm going to modify so that I can get the differential function here, which is 2x. So when we multiply by 2, the equation have to divide back by 2. so that this question doesn't change. It still have equivalent in value. But we can get this pattern. So this is our EFX, where the differential function is at side here. So to integrate this, it will bring us back to EFX only. So 1 over 2 EFX, where upper limit is 2, lower limit is 0. So for this, we can use our formula number 2, individual x, where power plus 1 over new power. So after we integrate, we're going to substitute the upper limit minus the lower limit. And we figure out this.